Okay, so now that we talked about Lewis dot structures, you understand the connection between a molecular formula and a Lewis dot structure. We're now going to talk about what we can get from a Lewis dot structure, namely shapes and polarity. Okay, so for example, in a molecule of methane, in a molecule of methane, in a molecule of methane, the central atom, C, is bonded to 4 sulfur atoms. And we get this from the Lewis structure. You've done this already, okay? So here's the molecular formula. We get the Lewis structure from it, right? And then after that, we find out that the best shape of this, the best geometry for this, is tetrahedral. And that is, it looks like a 3-sided pyramid here with bond angles of 109, or about 110 degrees, okay? So we're going to talk in this video about how to predict the 3-dimensional shape of a molecule given its Lewis dot structure. And then we'll do this in 2 different videos. In the next one, we'll see how that you can tell by its shape if it's polar or nonpolar. All right, so first of all, let's talk about valence shell electron pair repulsion theory. Valence shell electron pair excuse me, repulsion theory, okay? This is a theory that's set up to describe the orientation of electron groups around a central atom. Excuse me. And it states that electron groups are arranged as far apart as they can get around the central atom, and also that the specific shape of a molecule is determined by the number of atoms and lone pairs of electrons around the central atom. Okay, so let's start out with talking about central atoms and a molecule with a central atom that has 2 electron groups around it. All right, so first of all, an electron group is a bond or a single bond, a double bond, or triple bond. So here's, if this is the central atom here, then this carbon atom has got 2 electron groups around it, right? In a molecule of carbon dioxide, 2 bonding electron groups are placed around the central atom, carbon, which we have. The repulsion is minimized. These guys repel each other. These 2 oxygens, they don't like to be close to each other. And this repulsion is minimized by placing the 2 groups on opposite sides of the carbon atom. And it gives it a shape that we call linear, okay? And it has bond angles of 180 degrees. This can be memorized. It is intuitive, but you could just simply memorize it, right? The shape of the 2 electron groups around the central atom is called linear. All right. Now, if we have a central atom with 3 electron groups around it, right? Let's talk about formaldehyde, for example. If the Lewis structure for formaldehyde is this is a little more complicated than most of the ones that you draw, but if that's the Lewis structure of formaldehyde, then you would find out that the 3 electron groups are placed around the central atom, carbon, and there they are. There's 1 electron group. There's another electron group. There's another electron group. The repulsion is minimized by placing the 3 groups as far apart as possible. And in that case, they get to be 120 degrees, right? And they lie in a plane. And so we call it trigonal planar. All right, another example of a molecule with 3 electron groups around it is if one of your electron groups is a lone pair of electrons. So here's an electron group for sulfur dioxide. Here's an electron group. And here's an electron group, okay? So in a molecule of sulfur dioxide, there are 3 electron groups around it. There's a single bonded atom, there's a double bonded atom, and there's a lone pair of electrons. This repulsion is minimized, the same as in the last one. It's minimized by placing the electron groups as far apart as possible, as always. And the shape with 2 bonds on a lone pair is bent. We call it bent, and that's the reason why. Okay, it turns out this lone pair of electrons is pushing these 2 out of line, and it makes about 120 degrees. Okay, that's really counterintuitive. You're going to have to look at that twice. That lone pair is actually a big bubble. It's a big cloud of electrons. It's hard to see. It looks like it's just 2 dots there, right? But it's actually really big. And so it's pushing those oxygens out of plane, and it gives this, the shape of this molecule, we're going to call a bent shape. Okay? If we have a molecule with 4 electron groups around it, this is how we started the conversation, we would say that in the example of methane, right, there's our 4 electron groups, The repulsion is minimized by placing the 4 electron groups at corners of a tetrahedron, that is a 3-sided pyramid, with bond angles of about 110 degrees. The shape with 4 bonds in the central atom is called tetrahedral. And you can maybe see that, right? That's, right? Equilateral triangles, equilateral triangles. And there's 4 of them, 3 on top and 1 in the base. Okay, it's 4 faces, and it's about 110 degrees. Okay, another molecule with 4 electron groups is ammonia. And ammonia has 4 electron groups, 3 bonds to a hydrogen atom. There's 1, there's 2, there's 3. And then the 4th one is a lone pair of electrons. Okay, the repulsion is minimized by placing the 4 electron groups at corners of a tetrahedron with bond angles of about 110. Okay, about 110 degrees. The shape with 3 bonds and a lone pair is called, not tetrahedral anymore, it's called trigonopyramidal. Okay, and here's another example then of a molecule with 4 electron groups, water, right? So that's got 1 electron group is a lone pair, another lone pair, an atom, and an atom. There's 4 groups, and they go to the 4 corners of a tetrahedron, right? And they also have a bond angle of about 110 degrees, okay? The shape with 2 bonds and 2 lone pairs is called bent. All right, so can you see that we need the Lewis dot structure in order to be able to predict what the shape is? All right, so here's a table from your text, table 6.17, and it sort of just helps you walk through it, right? If you have a molecule with 2 electron groups and it's 2 atoms and no lone pairs, we would say it's linear and its bond angle is 180. An example of that would be carbon dioxide. If we have a molecule with 3 electron groups, its electronic geometry is trigonoplanar. If it's got 3 atoms and no lone pairs of electrons, we would say that its molecular shape is trigonoplanar and its bond angle is 120. Okay, if you have a molecule, another example of a molecule with 3 electron groups might have 2 bonds and 1 lone pair of electrons, which we did with sulfur dioxide a couple slides ago, and we found that it has bond angles also of 120, but we call its molecular shape, we call it bent, because that's what it looks like, right? There is a lone pair here, but we don't use that lone pair when we're defining its shape. Okay. And if you have, the example we used was methane, if you've got 4 electron groups, 4 atoms, 0 lone pairs, it's going to have bond angles of about 110, and we're going to call that tetrahedral. With ammonia, that also had 4 groups, but 3 of them were atoms, and 1 was a lone pair of electrons, and we found it also had bond angles of about 110, and we called it trigonopyramidal. It's ammonia, okay? And then, of course, water, which we've done. I know I'm just reading this table to you. 2 bonds, 2 lone pairs of electrons, and that's also going to be about 110 degrees. We call that bent. By the way, notice that this bent and this bent are not the same. We call them both bent, but they have different bond angles. One's 120 and one's 109. All right, so let's do a practice, and then we'll close this conversation out and move on to the next one. So predict the shape of the molecule H2S. So you're given a molecular formula, and you have to draw the Lewis dot structure. Then you've got to just go to table 6.17 and decide what that means, okay? So pause the video and do that now, table 6.17, and then come back and compare your answer to mine. Okay, so I'm going to suppose that you paused it, and I'm going to draw the Lewis dot structure for H2S. Sulfur's in group 6. I went kind of fast on that. Sulfur's in group 6 and hydrogen's in group 1. So it's going to look like that. I'm going, what? That looks like water, right? It looks just like water because sulfur's right below oxygen in the periodic table, right? So let's go up here and see if it's got 2 bonds and 2 lone pairs of electrons, its shape is going to be bent, and its bond angle is going to be about 110. Whoa, let me go back over here. I was supposed to predict the shape of it, and so I'm going to say that that is bent. Okay, so let's conclude this conversation with the question: the A, B, and C, for all three of these, please determine the shape of the molecules or ions as tetrahedral, trigonopyramidal, or bent. Pause the video and come back and compare your answers to mine. Okay, so let me go through this kind of quickly. PF3. I know phosphorus is right below nitrogen in the periodic table, so it's going to look kind of like nitrogen does. Taking a long time for those electrons, right? All right, and so I see, aha, it has 3 bonds. And 1 lone pair of electrons, 4 electron groups. But it's one of those is a lone pair, and so it's going to be trigonopyramidal. Trigonopyramidal. Okay, let's do another one. Let's do water. We already did water. It's got 2 bonds and 2 electron pairs, and we're going to call that bent. Right? And then finally, let's do the last one. Let's do CCl4. I don't want to draw all these lone pairs of electrons, okay? So I'm just going to draw the ones around one of the chlorines, and I see, aha, it has 4 electron groups, no lone pairs of electrons, are all atoms. And so we're going to call this tetrahedral, okay? So you're going to need to practice this before you like it, but hopefully that's a good clean introduction to to molecular shapes.